Okay, today's lesson was about unit cubes. It's a pretty easy lesson, but there's a couple of questions at the end of the homework that might be a little bit challenging. But it's related to our last chapter, which was on volume, which included volume. So once you look at it that way, you'll see that it's pretty straightforward. So let's start with this problem. Lucas covers a rectangle with 5 rows of 4 unit cubes. Then he stacks identical layers to make a prism. How many cubes does Lucas use to make 4 layers? So we've got 5 rows of 4 cubes. So let's say we have a rectangle here. And I cut it up into 5 on one side and 4 on the other. Okay, so that's this first part. Then he stacks identical layers to make a prism, and he has 4 layers. So if we stacked these cubes together and then made this 4 layers, the area of this this bottom part would be 4 times 5, or you can think of it as volume because this is 1 unit high. So it'd be 1 times 4 times 5. It'd be 20 units cubed times 4, and because we have 4 of these layers, and 20 times 4 would be 80 units cubed. Another way to think about it is this is actually a it actually says that in the problem. This is a prism. It's just a rectangular prism. Okay, so we can think of it like that. And we have, let's say, 4 going this way, a height of 4, a width of 4, a length of 5. That's what's being described here, and we remember that. And it wants us to ask how many cubes there are. Well, that's basically, and each cube is worth, is a unit cube. It's 1 by 1 by 1. So the volume is just going to be the number of cubes in here. So 5 times 4 is, volume is width times length times height, and that is 5 times 4 times 4, and that's 20 times 4, and that's 80 units, unit cubes, 80 unit cubes. Notice that this sounds very similar to 80 cubic units. That's not a coincidence, because when we are finding the volume, we're basically counting how many cubes are inside of something. If you cut it up into unit cubes and you count the number of cubes, you're going to get that many. Okay? So for this problem, we have, it's multi-step. Owen wants to make a rectangular prism with a length of 6 cubes, a width of 3 cubes, and a height of 4 cubes. He has 54 cubes. How many more cubes does Owen need? So he has 6 cubes, a length of 6 cubes, width of 3 cubes, and a height of 4 cubes, and he has 54 cubes. How many more cubes does Owen need? Now notice I'm using a technique here that we call UPSI. Well, at least parts of it. What I encourage them to do with a problem like this especially is to box all the keywords and circle the numbers, and then reorganize the information so that it makes sense, so that, because a lot of times students look at problems like this and then they don't know what to do. So this helps break it down. So length equals 6, width equals 3, height equals 4. He has 54 cubes. So I can boil down the problem to just this. So how many more does he need? Well, I can think of this in terms of volume, which we already know. Volume equals length times width times height. Length is 6, width is 3, height is 4. So it's 6 times 3 times 4. And 3 times 4 is, let's say 6 times 3 is 18. I multiply that by 4. 8 times 4 is 32. 4 times 1 is 4, plus 3 is 7. So he needs 72 cubes to make this prism, but he only has 54. So how many more does he need? Well, we subtract 72 and 54, and we get 18 cubes. That's how many more he needs.